Everyone thinks clocks are rock solid, but in reality, clocks are the most fragile signals in your entire system. Let's break down why. A clock signal doesn't carry information in the way a data line does. It carries something far more fundamental: time. Every single flip-flop, every register, every bus in your circuit operates on one simple assumption: this clock edge will arrive exactly when I expect it to. This shared sense of time is what allows millions of transistors to work together in perfect harmony. But here's the catch. Clocks are unique. They are incredibly high-frequency signals. They have to travel across the entire chip, making them global. They are always switching, constantly consuming power, and they're connected to almost everything. This combination makes them extremely sensitive to all sorts of problems. Think about noise from the power supply, slight variations in the physical impedance of the trace's crosstalk from neighboring signals, or even tiny dips in the power grid. Now, imagine a small disturbance hits a data line. What happens? You might corrupt a single bit of data. Annoying, but often recoverable. But what happens when that same tiny disturbance hits the clock line? It doesn't just corrupt one bit, it corrupts the very foundation of time for the entire system. Suddenly, data might be captured a nanosecond too early, or a command is executed a moment too late. Everything that relies on that clock edge is now out of sync, and the entire system's behavior becomes unpredictable. It's like trying to conduct an orchestra where every musician's sense of rhythm is slightly different. The result is chaos. And here's the part that most explanations miss. The part that makes clock issues so maddening to debug. Clocks don't fail loudly. They fail silently. You won't get a crash report. There's no convenient error message popping up on your screen. Instead, you get these strange, ghostly problems. Random glitches that happen once in a blue moon. Rare timing violations that seem impossible to reproduce. And the worst ones, bugs that mysteriously disappear the moment you connect a probe to debug them, because the probe itself changes the electrical characteristics of the circuit. Engineers will spend weeks, even months, chasing what they think are firmware bugs. They'll blame the compiler for generating bad code, or they'll conclude they just have a batch of unstable MCUs. They'll swap out components, rewrite software, and question their own sanity. All while the real culprit is hiding in plain sight. The integrity of time itself has been compromised. So remember this key difference. Data can be wrong, and the system might still function, perhaps with some errors. But when time itself is wrong, logic stops making sense. Stay sharp.